Alright, okay, so I guess this is going to be the fourth video of 5. Yeah, I thought it was going to be 4 videos, but I figured just split this into 2 parts, probably easier. Okay, but anyway, this is section 11.3. This is applying properties of similar figures, part 2. Okay, so these are the notes that I gave in class. So yeah, properties of similar figures can be used to find the measures of corresponding parts. So here, this is just a layout of how you would solve for x and how you would solve for y. Main thing is, just like in the other examples that we went over, angles of similar figures are going to be congruent to each other. Congruent meaning the expressions are going to be the same. So 4x plus 27 equals 95. You can solve for x. For y is slightly different. Okay, and this is actually pretty important. Again, like I mentioned in class, I would say at least 1/4 of your test will come from this. I'm not sure how many points it is. I would say, yeah, at least 1/4, maybe close to 1/3 of your test will be based off this. So it'd be good to understand how this works. Okay, so the way to do this is to just do, if you wanted to look at these proportions, this big side is going to be proportional to this little side, and you got to make sure the other big side is proportional to the smaller side. And then here, if you don't know how to cross multiply, please make sure you understand how to cross multiply. That's the purpose of the warm-ups and why I've been doing it so much in class recently. So here, this, if you do the butterfly thing, you have this here and this here. If you cross multiply, that's how you get this line here. Then here you distribute the 10. That's how you get this line here. Then you want to solve for y. If you solve for y, subtract 30y on both sides, divide by -10. That's how you get y equals 5. Okay. Yeah, I believe you guys should be, most of you should be okay at solving algebra problems. I know some not as good as others, but it's okay. But anyway, that's the brief overview or like introduction to what the other type of problems are that I have here. Okay, so the one that we went over in class was letter B. Okay, so okay. So this is letter B right here. So this one, it says find the value of x. Okay. So what I see here is that it's giving you the measure of angle LMN equals the measure of x, y, z. So this one, if you want to solve for the value of x, just write out the expressions. This is 5 times x minus 5, and this is going to be 4x. So again, corresponding angles of similar figures are going to be congruent. They're going to be equal to each other. That's why they have the equal sign. So if you went and distributed, this is going to be 5x minus 25 equals 4x. Okay. You know what? I'm just gonna just ignore all this. I like to show you all the steps. I know in class the way we did it, we just did it line by line, but I just want to show you all the steps. Okay, so I want to solve for x. Subtract 5x on both sides. So this cancels out. This is -25 equals, so 4x minus 5x. 4 is a smaller number, 5 is a bigger number. You're going to have a negative. So this is -25 equals -x. You can think of it as a -1x if you wanted to. So next, our goal is to solve for x by itself. You can just divide by -1. Divide by -1, you get x equals 25. Okay. This next part here, so find the value of y. So it gives you the proportion. So JK is going to be proportional to VW. Okay. So usually the trick to these similar figures or similar triangles problems is you want to find something that is proportional, that is whole numbers, so that you can actually solve for your unknown variable. Okay, so what I see here is that we use this information here. These are angles, so we're not going to worry about that. The only ones we're going to worry about are the sides. So this here and this here. So from here, I can use this here, this 1.5, and well, these sides here are going to be proportional. JK is proportional to VW, and this is, so MN is going to be proportional to YZ. So if I went ahead and solved this, this is 2y minus 8 divided by VW, which is 4, MN, which is 1.5, YZ is 1. So from here, what I'm going to do is I'm going to cross multiply. So if I do the little butterfly thing, I know you guys like the butterfly. Okay, so I'm just going to cross this out. You know what, I'm just screw it. I'm just going to show all the work here. Okay, so this is 1 multiplied by 2y minus 8 equals 4 times 1.5. Here, if I distribute the 1, it's going to be the same. 2y minus 8. 4 times 1.5 is 6. Okay, so now I'm going to get y by itself. Add 8 to both sides. This is 2y equals 14. Then I want to get y isolated by itself, divide by 2. So that means y equals 7. Okay, so that's how you solve for x. That's how you solve for y. Okay, so these are the other sets of problems that we did in class. Okay, so using the diagram in which triangle ABE is similar to triangle ACD. Okay, find the value of x. I notice this angle is same as this angle. This one's pretty straightforward. 3x plus 14 equals 50. If you went and solved it through, subtract 14 on both sides. This is 3x equals 36. Divide by 3, x is 12. So that's how you solve for x. Okay, y was the fun one. Okay, so one way to think about this is, let's say I were to redraw these triangles. So let's see if I make this here. Okay, so we only want to consider ABE, triangle ABE, and ACD. So I'm going to redraw ACD so you can kind of visualize it. Okay, so this is 5. To find the length of AD, notice this is 5.6 and this is some length. So in order to write an expression for AD, this is going to be 5.6 plus y. If you think about this, this is the segment addition postulate way back in module 1, which says that this segment plus this segment has to equal the whole thing. So 5.6 plus y gives you that there. Okay, if you guys wanted to visualize the other triangle, so the other triangle here, so this is A, E, and B. So AE is 5.6, and then we know that BE is 4. Now looking at these two triangles where ABE is similar to ACD, we now have enough information to solve for y. Okay, so now what you would do is, let's see, I'm going to just do the smaller one over the bigger one. So AE over AD equals BE divided by CD. Okay, so AE is going to be 5.6. AD is going to be the sum of 5.6 and y, so 5.6 plus y. BE is going to be 4. CD is going to be 5. Okay, from here you want to do your little cross multiplication, do your pretty butterfly. So 5.6 times 5, this is going to be 28. Then this is, the other part is going to be 4 multiplied by 5.6 plus y. If I were to distribute the 4, this is 28 equals, this is 22.4 plus 4y. Okay. Next, what I want to do is I want to isolate the y by itself. So subtract 22.4 from both sides. this is going to be 5.6 equals 4. Why? Finally, divide by 4, and then you get y was 1.4. Okay. So that's how you would do numbers 8 and number 9. Okay. I'm going to show you the other examples that we did in class. So I believe that was numbers 15 and 16. Okay. Numbers 15 and 16. So now these are problems. This one up here doesn't have any letters. So you might think, oh, what do I do? Okay. So just like how we've done previously. Now, you could do the small. You can compare the small and the big over the small equals the small over the other big, or you could do the opposite. So let's say I wanted to do the other way. So let's say I'm going to take this big side, so x plus 1, I'm going to compare it to the other slanted side, so this is x minus 3, and this equals, so this is going to be the long side, which is 6, and compared with the shorter side, which is 3. Now the order of how you set this up is important, otherwise you're going to get a whole bunch of different answers. Okay, so if you know that the figures are similar, you want to find the value of x, you do your nice butterfly cross multiply. Okay, so from here, this is 3 multiplied by x plus 1, and this is 6 multiplied by x minus 3. Okay, you can do your lovely distributive property. This is 3x plus 3 equals 6x minus 18. Okay. Then you can solve for x. So what I see is you can subtract 3x on both sides. So this is going to be 3 equals 3x minus 18. I'm going to run out of room. I'm just going to write it here. So add 18 on both sides. You add 18, this is 21 equals 3x. So divide by 3, and you get x equals 7. That's how you solve for x. This one, number 16a, which is the only one we did in class. This one is a little bit different. Okay, but it's also very easy. So NPQ is going. The triangle NPQ is going to be similar to triangle NLM. So what this implies, I see this angle is going to be the same as this angle. Okay, so angles. Corresponding angles have to be congruent to each other for similar figures. Okay. 3x plus 18 equals 60. Then you solve for x. So this is going to be 3x equals 42. Divide by 3, x equals 14. Yep. So that one was on the easier side. Okay. That's just a quick recap of what we went over recently. Okay. That's it for section 11.3. Okay, and I'll go over 11.4, which is the next couple problems. Okay.